Good day. So today I'm going to show you how to find the derivative of something using first principles. So when they say use first principles, they're talking about this method. So I'm going to show you how to derive a straight line graph, a parabola, and a cubic graph using first principles. So all three of these are going to be dealt with in this video. So before we start, let's deal with something that has been giving a lot of students a challenge. So a lot of students get a challenge. They're challenged when it comes to solving this part, right? When it comes to substituting this part. So let's deal with that. Let's build the skills on dealing with this part. Then I will explain the other things like what does this mean and how to go about this method. So let's begin. Let's just say we have f at x is equals to 2x plus 3. So if they ask you f at 2, you would literally substitute everywhere you see x would put 2, so you say 2 into 2 plus 3, so in place of x would put 2. Or if the f at z, it means that wherever you see x you will just replace it with z. So that is what it will literally become. Or if they put f at x plus 1, it means wherever you see x you would literally replace x with x plus 1. So instead of writing x, I wrote x plus 1. Or if they say f at x plus h, it means wherever I see x, I will take x and I will replace it with x plus h. So this is where most people struggle. So let's do one more example of it. Let's say f at x is equals to 2x squared plus 2x plus 3. So now if they ask for f at x plus h, let's just say f at x plus h. So if they ask for f at x plus h, it means that wherever we see x, we will take it and replace it with x plus h. So since x appears here as well, we would replace it with x plus h. So if you look at this, you'll see that the equation is exactly the same. It's just that in place of x, I put x plus h. So that's how you substitute this thing. Just before I continue, if you want to be tutored, either online or physically, online it doesn't matter where you are or which country you are at, you can still be tutored. So we offer cheap online lessons, and if you want to be tutored physically, we can still make an arrangement. So call or WhatsApp this number, but preferably please WhatsApp this number, and then we will take it from there. So what I do is that I tutor people 5 days a week online, and I give tests once a week so that I can check your improvement. So let me explain this limit as h tends towards 0. There's a deeper explanation, but I'm going to give you an explanation that will enable you to be able to do this thing and still get total. So limit as h tends towards 0, we're saying it's approaching 0, it's not at 0. Our goal is to make h to become 0. But the reason why we can't put 0 is because if we put 0, anything over 0 is undefined. We can check in the calculator. For instance, if we say maybe 100 over 0, it's undefined, right? The calculator gives you error. So we cannot put 0. So our goal is to get rid of h. I'll show you how to do it. Our goal is to get rid of h. Once we get rid of h, we can make it 0. But since we can't get rid of h yet, we have to say limit as h tends towards 0. So we're telling them it's not at 0, it's approaching 0. So h is not at 0, it's approaching 0. So we tell them limit as h tends towards 0, right? So our goal is to remove h from the denominator, then we can make it 0. But as long as we have not removed it from the denominator, we can't make it 0. So every step where we have not removed h as a denominator, we still have to say limit as h tends towards 0. And I will re-explain this again in the video. With level 1, let's just say we have f at x equals to 2x plus 3, right? And then they say find the derivative from first principles, meaning that you have to use this method. So we're going to start. So let's substitute into the formula. Okay, I just had to shift it there. Okay, let's substitute into this formula. So this formula says limit as h tends towards 0. Notice the equal sign is before it, right? It's not after it. So we'll say equals to limit as h tends towards 0. So now let's substitute f at x plus h. So it means wherever we see x, we have to replace x with x plus h. So notice I wrote the formula exactly the same. It's just that in place of x, I put bracket x plus h, right? And then from there it says minus f at x. So f at x is exactly the same thing. So we'll say minus f at x, which is 2x plus 3. But this is the mistake that people make. They just write it without putting brackets. Remember, when we substitute one thing and it becomes a lot, we have to put it in brackets. You see, because this negative is multiplying everything. So this negative will multiply everything. So always remember that when you substitute something, when you make one thing to become a lot, you have to put it in brackets so that whatever was in front of it can multiply throughout. So this is where other students miss it. So they don't put brackets. And then we have over h. And then from here, now we can distribute. So the next step will still say limit as h tends towards 0. As long as h is the denominator, we'll say limit as h tends towards 0. So let's distribute. So then this is going to be 2x plus 2h plus 3 minus 2x minus 3. We're just distributing. And this is going to be over h. So then if you notice, when you look at this stuff, you have to cancel like terms. But here's the secret so that you don't waste your time checking what cancels with this, what cancels with this. It's very simple. Everything that does not have h will obviously cancel. So this does not have h, it will cancel with this. This has h, so it won't cancel. Then this does not have h, so it will cancel with this. You see? So everything that has h always remains. So let me just continue on top there. So everything with h remains. Everything without h obviously gets cancelled. So the next step, you still say limit as h tends towards 0. Matter of fact, if you don't have limit as h tends towards 0, you do lose a mark there. So because all this cancelled and it was only 2h that remains, it means it's 2h. So now we can cancel h. You see, basically we could not cancel h before. We can't cancel when there are many things at the denominator. There has to be, at the numerator, there has to be one term, right? So I'll explain it I'll explain that again. So then we're able to cancel this stuff, right? So when we cancel it, we can now remove limit. So we'll say it's equals to 2, right? So if there is h, if there is still an h, we can make h to become 0. You'll understand it clearly now when we go to the parabola. So this is the straight line graph, so it's easy. That's why h cancels and there's no h. So now we've removed h from the denominator, so we can now remove limit as h tends towards 0. But if there was an h that remained and we're done with the denominator, we would replace h with 0 and get the answer. You'll see that with more examples that I'll do just now. So the answer just remains f prime x is 2. The first derivative is equals to 2. Okay, let me show you an example for a parabola. All right, so let's say they want you to find the first derivative of this using first principles. So of course, first principles, the formula is f prime x is equals to limit as h tends towards 0. Then we've got f at x plus h minus f at x, sorry, it's not plus, minus f at x. So we have minus f at x all over h, right? So hence this is the formula. So now let's substitute into the formula. So we obviously still gonna say limit as h tends towards 0, right? We still have h as a denominator, so h cannot be 0 as a denominator. So we have to say this. If we don't say it, we lose the mark. So then let's substitute for this. It means that this, everywhere we see x, will replace it with x plus h. So it means I'll write 2, then instead of writing x, now I write x plus h. Right? And then now plus 2, and then instead of writing x again, I would write x plus h. And then plus 2. So let me just rewrite this. All right, just had to create more space. So in place of, instead of writing x, I just write x plus h. Then I said minus. So f at x is the normal equation. But the mistake that people do is that when they put it, they don't put brackets. You have to put brackets. So then we're going to say minus the exact equation. So we have to write that in brackets. And then we will have over h. And then now we have limit as h tends towards 0. All right, so then we have to expand this bracket, right? Because we have bracket squared. But I'm going to use the shortcut. So the shortcut In another video I do show, I'm gonna put it in the description below, where I show how to do the shortcut of this stuff so that you don't waste your time writing two brackets and expanding. So hence this is the shortcut. So I just expanded it. So expanded this bracket. I'm not gonna distribute. I choose not to distribute now because I haven't distributed this yet. You can choose to distribute, it's no problem, but I'm just gonna keep it like that for now. And also this, I'm not gonna distribute, I'm just gonna keep it the same. Alright, so then on the next step, that's where I'm gonna expand it. So limit as h tends towards 0, we still have to keep this. Then we can distribute. So now let's distribute. So then that's gonna be 2x squared plus 2 times 2, which is 4hx, and then plus 2h squared, then plus 2x plus 2h plus 2 minus 2x squared minus 2x minus 2. Okay, then obvious. Let's start with the cancelling. So the things that will cancel are obviously the things that don't have h. So I know that this will cancel with this. And then this is h, it won't cancel. This is h, it won't cancel. This does not have h, so it will cancel with this. And then this 2h will not cancel because it has h. This 2 is a constant. It will cancel with this -2. And then we're done cancelling. So on the next step, let me just write what remains. So on the next step, we have limit as h tends towards 0. So we have 4, this is what was left, 4hx plus 2h squared plus 2h. So our goal is to get rid of the h at the bottom. So we can't cancel because there are many terms, right? So we have to factorize. Even in trigonometry, we factorize in order to cancel. So let's factorize. So limit as h tends towards 0. So let's factorize. What is common is 2h, but I'm just going to factorize h because my goal is to cancel h. So then I'm going to factorize h. So it's going to be h, then it's going to be 4x in the bracket, then plus 2h, then plus 2. That's what's going to remain in the bracket, all over h. So far that's what we have. And then from there, we can cancel this. So then we can say limit as h tends towards 0. So we have reached our goal. We have removed h from the denominator. So now keep it like this. Then now when we substitute 0, that's when we can remove limit as h tends towards 0. So here I'm telling them it's not at 0, but on the next step I substitute 0. So the part where we substitute 0 is the part where we have to remove limit as h tends towards 0. So we substitute 0. Then 0 times 2 is obviously 0. So then the first derivative will be 4x plus 2. And that will be our answer. So we keep this limit as h tends towards 0 at every step. But now when we make it 0 finally, that's when we remove limit as h tends towards 0. So by the way, there's no mark for showing this step where you put h as 0. You are actually allowed to just go straight to the point. We know that if h is 0, this is gonna disappear and you can just write this immediately. But if you want, you can write this step, but there's no mark for it, right? You can just move from saying, oh, I know that if h is 0, this will disappear and it will just be left 4x plus 2, and you immediately write it down. But you're allowed to do this step. So just remember the fact that we keep this thing limit as h tends towards 0, right? Lim stands for limit, so as h tends towards 0. Then finally, when we make h 0, that's when we remove it. We can't say limit as h tends towards 0 and at the same time we put 0. It's like we're saying it's not yet 0 and at the same time it's 0. It doesn't make sense. So when you make it 0, that's when you remove this step of limit. So we couldn't put 0 at the beginning because if we put 0 as a denominator, it would be undefined. But when we get rid of h as a denominator, then we're finally allowed to make it 0. So let me show you an example with cubics. Here is the cubic version of it. So let's just say we've got f at x equals to 2x cubed. Let's just say plus 4. Alright, and let's just say find this from first principles. So then of course we know that first principles f prime x is equals to limit as h tends towards 0, meaning as h approaches 0. Then we've got f at x plus h minus f at x all over h. So that's what we have. So then let's substitute. So we know that it's going to be limit as h tends towards 0. Then instead of writing this, instead of writing x, I'm gonna replace x with x plus h. So I write exactly the same thing, but instead of writing x, I write x plus h all cubed, and then I'll say plus 4, then minus. Then now instead of now we're no more dealing with x plus h, now we're dealing with f at x, which is the original equation. But now you have to put brackets. That's what you have to be careful of, because we changed one thing to become many. So then we're going to put this in brackets. So then that's what we have. Then all over h. Then from there we're going to say limit as h tends towards 0. And then from there, we're going to have to expand it. So let's expand it. Okay, I choose to expand it this way, where I will have. But you can expand it into 3 brackets if you like, and you can just multiply. But I choose to expand it into 1 bracket and 2 brackets because we know the shortcut of this. There is the shortcut for cubics, but I usually don't choose to use it. All right, so then this is 2x cubed plus 4. Then from there, we're going to say again limit as h tends towards 0. We always have to put this step, except where we make h 0 after removing h from the denominator. So then from here, we're going to say 2 into x plus h. Then we know the shortcut of this, so this is going to be x squared plus 2hx. So it's plus 2xh, or rather 2hx plus h squared. And then plus 4, then minus. So I don't choose to distribute the signs now. I could, but I don't choose to. Okay, so from there, I've got all over h. Then let's go to the next step. Limit as h tends towards 0. So then now we're going to multiply. So the only thing about cubics is that it becomes longer, right? That's the only thing. So whenever you've got 3 things, my advice is to multiply the last 2 things first before the first one. So for instance, let's just say we've got bracket x plus 2, bracket x plus 4, bracket x plus 1. My advice is to multiply the last 2 before dealing with the first. Then the last 2 will end up becoming one big bracket. And then from there you multiply with the first bracket. So that was just an example. Let's just proceed. So since we've got 1, 2, 3 stuff, it's better to multiply this. So you can still multiply that, there's no problem, but in other algebraic situations, there are some things that confuse people. Okay, so let me multiply. So let's multiply. So when you multiply, this is going to become x cubed. So we're going to have x cubed plus 2hx squared plus h squared x. Okay, so then let's go to the next step. So the next step, obviously, we'll say limit as h tends towards 0. So then we're going to distribute, but it's better to find like terms. Let's do it like terms inside. So obviously x cubed does not have its like term. And then hx squared and hs squared, you see the like terms. So it's just like 2x plus x, which becomes 3hx squared. And then h squared x and h squared x, you see the like terms. So then this will add and it will just become 3h squared x. And then from there, we have h cubed. All right, then we're gonna have plus 4 minus 2x cubed plus 4. Okay. Then let's go to the next step, limit as h tends towards 0. So let's distribute. So when you distribute, it's gonna be 2x cubed plus 6hx squared plus 6h squared x plus 2h cubed plus 4. Then since I distributed this side, I'm also going to distribute this side. So then this is going to be 2x cubed minus 4. Here it was a plus 4, so when we distribute, it's going to be minus 4. And then now it's time to cancel the like terms. So obvious, everything that does not have h will cancel. So this is going to cancel with this. This is h is not going to cancel, it's not going to cancel, not going to cancel, but this is going to cancel with this. So then what is left is 6h x squared plus 6h squared x plus 2h cubed. Okay, then we're going to have all over h. So in order to cancel, we have to factorize. So then we're going to factorize. So we'll still say limit as h tends towards 0. Then let's factorize h. So if you factorize h, this is going to become 6x squared plus 6. Yep, that's what we're going to have. 6hx plus 2h squared all over h. So then this is going to cancel. Okay, so in the next step, we're going to have limit as h tends towards 0. Then we're going to have 6x squared plus 6hx plus 2h squared. So that's what we're left with. Then we're gonna make make h 0. So if we make h 0, these two are gonna disappear, and we're only gonna be left with 6x squared. And of course, I remove the limit as x tends towards 0. Or if you want, you can write that step, the one that does not give you marks. You can just say 6x squared plus 6, and you make h 0. So 0x plus 2 into 0 squared. And then we'll be left with 6x squared as our answer. Alright, so if you enjoyed this video, if you have a question, you can just comment on the section below. And if you enjoyed this video, please like and subscribe. If you want to be tutored, please WhatsApp me according to the numbers that I provided in the advertisement. Alright, see you in the next video.